this and how control you are when you ask you to read Romans chapter 8, verses 38 and 39. I am convinced that neither life nor death, angels and demons, nor the past nor the present nor any knowledge. Zachary, are you with me on that? I really should just record all this and just let you watch it. Write this big word on your paper there. Sets, ladies and gentlemen, sets. You sure we didn't do this because this seems awful familiar?
Yeah,
Thank you. I knew somebody would come up with it. A set of A numbers is basically nothing more than a group. And we use some special little symbol to show sets. Does anybody know what that is? It's pretty much my favorite mathematical symbol to make. Joseph, it's a...
I don't exactly know.
Yeah.
The brace.
Correct. It's a brace. You put whatever that group of numbers is inside there. That is your set. And then we have like 3 different types of set we can talk about. We can have a set that has nothing. Oh boy. A set that contains nothing. A set that contains goes on forever. And a set that has a beginning and an end. And these are the words. I mean, a nothing set, ladies and gentlemen, we call, just like playing tennis, although I think tennis isn't it nil. Do they say nil?
Soccer's nil.
Soccer's nil. Well, anyways, when you have nothing in this set, it's a null set. Also, null set, I hope I'm right. Do you ever think that sometime I could just be saying stuff that's completely not true, you would have no idea?
That's like band.
That's who?
It's like band. You never know. Like, if you went into an actual band.
I would say that's exactly it. How do you know that the letters are, where, I just saw it, there it is. Oh, null or empty. Sorry, I knew there was a null word. It's a null or empty set. And do you know how you show null or empty?
Nothing.
Anybody? Cassie? Null?
Drawn to it.
This is a null set. You do the 0 and you put a little slash there. It means there's nothing in there. And I don't know why they do it like that, but that's just it. Probably because if you put a 0 in there, that actually would be a set. 0 can be part of the set when you put a slash in there. A forever set means it is infinite. I don't know if we put a symbol inside that or not. Oh, how would an infinite set look? In order for a set to be infinite, like if I asked you to give me the counting numbers, that's an infinite set. How would you know it's infinite and goes on forever? Thank you very much. Yes. Wait, whole numbers? Did I say whole numbers or counting numbers? I think counting numbers. Counting numbers would be 1, 2, 3, and you really don't want to write them all down there, so you just do your little dot, 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 which is called a ellipse, elliptical. What is it? Ellipsis? Yeah, don't laugh at me. And then ones that have beginning and end, something has beginning and end just because you can count the numbers in it. Let's say it's just 10 and 12. That would be a finite set. Finite means you can count it. It can be grasped. Infinite means it goes on forever. You can't. Null, nothing, and you will probably never hear of sets again until you get to high school, but we might as well call a spade a spade. All right, and then when we talk about sets, ladies and gentlemen, oh, for example, let's do an example just so you can kind of get the gist of this. If I told you to write me the set of odd numbers, how would you show that? Well, it's a set, so you're going to do my favorite symbol there. What would I do inside those little braces there? Zachary?
1, 3, 5, 7.
Let's stop somewhere. And I'd have to go, what's that thing called again, Aaron? Ellipsis? But it's not only, odd numbers not only are the positive numbers, but you also have to go -1, -3, and the ellipsis going the other way. Okay, that would be the odd numbers, and even numbers would kind of be the same thing. And then in math, we have these other symbols we have to know when it comes to sets, and they are these. You gotta love it. Ready? Ready? We have this U shape. If this seems familiar, should we do this? Do we do the U shape? U means union. And the upside down U means the, somebody? Good, I'm glad we were intersection of sets. Union being means you put them together. You know, I have no idea why I know where they would start with this. Zero idea. None whatsoever. Intersection means what they have in common. And this will all come crystal clear to you when we do an example. I know you're waiting with bated breath. So here's an example. Here is what will make it clear to you. Let's say you've got set A, and set A is 2, 4, 6, 8, 10, and 12. Set A is this. I'm just going to give you the set. 2, 4, 6, 8, 10, and 12. Set B equals 3, 6, 9, and 12. 3, 6, 9, and 12. First day? The answer to that question is what? Brian, what's your answer? Feel free to say you didn't ask the question, because I didn't.
Did not ask.
I did not ask the question. That's a good answer there. Here is the question I have for you. A, U, B. And the question then on the table is this. You know that union means putting together. If I want the union of A and B, what set would that be? I guess I'll have to put it down here. Well, you put these two sets together, and you don't repeat any one. What would be the union of it? 2, 3, 4, 6, 8, 9, 10, 12. 2, 3, 4, 6, 8, 9, 10, 12. I have combined those two sets together. That is union. A little like marriage. You put them together. Union. Not to be mixed up with Maya. What would be the intersection of those, which would be upside down U? Which ones do they have in common? A much smaller set it will be because they don't have that much in common. What do they have in common? They have 6s, right? And they have 12s. The union would be 6 and 12. Does that make any kind of sense? Again, I feel bad because it really doesn't. I don't know why they put this here. But if you look, I'm not just making this up. Wait, Connor Morgan, you can look the first thing on page 2 and 3. They talk about those sort of things. Do you still have that little chart for the real numbers that I gave you back in the day? Did I give you one this year again?
Yeah.
Can you say that with a little less enthusiasm? Because at some point it got clear. And I don't know, do we need to talk about closure? How many of you need closure? Everybody need closure? Stace, you need some closure on this whole lesson? Yes, let's do it because it'll come up later. Ready? Last but not least, closure. Or just close. What does closed mean? Why don't you ask me that so I feel that you care?
What does closed mean?
Closed means, I'm going to read out a book because I can't explain a number. A number has closure or is closed under a given operation if the outcome of the operation of any two numbers on the set is also a member of the set. Here we go, ready? 'Tis closed under an operation if the outcome of the operation of any two numbers, this is great, outcome of the operation of any two numbers is also a member of the set. I should put this in. Of the set is also a member of the set. I'm going to ask somebody to explain that to me. I can tell you without a doubt, if I was your age, I would be baffled. Way too many words, makes no sense. Anybody think they know what that means? Maybe your eyes will be opened. Lauren Ulrich, you seem to know a lot about math. What do you think that means? Alright, let's talk about this. Let's say I have the set of, let's just pick a number, the set of counting numbers. First of all, you need to figure out what are the counting numbers. What are the counting numbers, Zachary?
1, 2, 3, 4,
and to infinity and
9.
beyond. Does Zach have that right? Everybody agree those are the counting numbers? Okay, so here's the deal. Here is what the book will ask you. I guess it would be is the set of counting numbers closed under addition? And what that means is this. Notice here where it said for any operation, addition is an operation. There's only a couple other ones. What are they? Addition, subtraction, multiplication, and division. Here's the question that asks you. Okay? Can you take any two numbers of the set that you know, add them together, and get something that is not a member of that set? For example, any two numbers. I say 3 and 6. If I add 3 and 6 together, I get 9. Is 9 also a member of the set that I was just talking about? Can you pick any numbers and add them together that would not be in this set? If that is true, then this is yes, it is closed. Yes, it is closed. I have closure. Now, just to whet, W-H-E-T, your appetite about this, is the set of counting numbers closed under subtraction? Can you pick two numbers that when you subtract them, you do not still get a counting number? And that would be what the book calls a counterexample. And Madison would say what? Give me two numbers subtracted that do not give me a counting number. 1 minus 1 is 0. Is 0 in our set of numbers? No. So this is not closed. Matter of fact, you could have picked any number like 1 minus 15. Anytime you get a negative number or a 0, that would not be in this thing here. Is the set of counting numbers closed under multiplication? Can you pick two numbers and multiply them together that will not give you? Can you pick two counting numbers, multiply them together, and get a number that won't also be a counting number? Gosh, that gets complicated, doesn't it? Joseph, what do you think? And if you don't know, pick one. Joseph, give me two counting numbers. And let's multiply them together.
1 and 2.
Oh, tough one. 2 times 1 is 2. Is 2 a counting number? Yes. Can you pick one that you would? Zachary?
1 times 0.
Yeah, but zero is not a counting number. I can't use zero because it has to be members of this set. So,
48 times 2.
yeah, 48 times 2 is 96. Is 96 also a counting number? Yes. So yes, counting numbers are closed under multiplication, it's closed under addition. Would it be closed under division? No, to which I would say, if you say no, I'd say give me a counter example, which you would say what? All you have to say is what divided by what? Give me something divided by something that won't give me a counting number. You should be able to think of billions. Joseph?
3 divided by 2.
3 divided by 2 is going to give you a fraction or a decimal, which is not a counting number. I thought that was particularly unexciting. Frankly, quite disturbing. All right, then. Ladies and gentlemen, welcome to algebra. Your assignment is lesson number 1. We've got a whole bunch of adding and subtracting fractions and all that stuff.